So if you followed along with the last video, you will have created this maze game where the player can move around with the arrow keys, and when they reach the X, they exit, and the game is over. And so we got a good skeleton, but there are a couple of things that we left to improve for next time, including we wanted to be able to load a level that we design in ASCIIFlow for our maze, which opens up the possibility of us getting to do some nice ASCII art design using a web tool rather than having to type the individual characters into our 2D array, which was really tedious. So here, let me create one really simply and put the goal over here. And what we can do is export this. So I'm just gonna copy, flip back to Visual Studio. I'm going to add, whoops, not a class. I want to add a new item, search for text, add a text file, paste this in, get rid of any empty new lines at the bottom. So now I've got my level here. It's got the goal location, a couple of things that the player shouldn't be able to walk through. So it's a really simple maze, and maybe I should rename this to be level 1. And to make sure that our text file ends up getting put next to our executable file when we hit build and run, we want to make sure that we copy to the output directory and choose always. So that'll mean that this gets bundled with our executable for our application. So now what we want to do is, instead of creating our grid like this, we want to load this text file. And we want to go line by line, character by character, and build out that 2D array of strings, but just use what's in this text file rather than having to hand code it like we're doing here, which, if we start putting them in text files, opens up the cool possibility that we could actually create multiple levels. So when you finish level 1, you get dumped into level 2, and the sort of challenge and difficulty ramps up over the course of multiple levels. So let's make a level parser. So we need to create a method that can read this in and turn it into a 2D array. And I think we should add another class that we can call level parser. And into this, let's create a public static method that returns our grid of strings, and we can call this parse file to array. And we will give it the path to wherever the file is located. It will give us back a grid of strings that we can then use in our level loader, in our world constructor. So this is the same thing that we are creating by hand inside of here. So we're just going to replace this line of code with the level parser. And we've covered this before in class, but quick review is the system.io namespace has a file class that allows us to read in text files. And in particular, it will allow us to file read all lines, and we can pass in the file path, which will give us an array where each element in the array is a string. So we're going to get an array with 12 elements here, and each one is one line from our file. So one of the tricks that we're going to need to do here is we need to know the number of rows and columns, and we need to measure the number of rows and columns from this file so that we can then create our array with the right number of rows and columns. So let's pull out the first line from our file. And we can use both of these pieces of information to calculate the rows and columns. So the rows, that's how many lines there are in the file. So that's just lines dot length. The number of columns is equal to how many characters are in each row. So we can just grab the first line and ask for its length. First line dot length. And let's fix this error. This is supposed to be a capital L. And now we have enough information to go ahead and construct our grid and set it equal to a new array where we tell it how many rows and columns we have. So we're going to return that grid But before we do, we need to make sure to fill in the elements in the grid. So we line by line, character by character. So we're going to go through each line. We're going to go through each character. We're going to put this in 0, 0. We're going to put this in 1, 0, this in 2, 0, and so forth until we reach the end. And then we can return the grid. So we want to use a structure like we've used before, like we did inside of game. Nope, we did that inside of world, where we're looping through all the rows and all the columns possible. So over here, we want to start a loop for y, and you could also use the variable row here. I like to think in terms of x and y. So y is less than the number of rows, y goes up by 1. For int x, and again you could use columns here, but I like to think in terms of x and y. So we're going through each row, so we're going through each line, and for each line we are going to go through the x coordinates, which is the columns. So for this we can, for each y, we can pull out the individual line, and then for each column we can grab the current character that corresponds to that column. So when we treat a string as an indexable element and we grab an index from it, we're going to get a character back. And this will be a problem if we try and use the columns and rows, or sorry, the row column, and just set it equal to current char, because it's telling us that it can't convert from a character, which is what this is, to a string, which is what we declared that this 2D array is. And so all we need to do here is ask for this character to be converted to a string. So we're going through each line, we're pulling out the line, then inside of the line we're grabbing each character one at a time, putting it into this grid, and then spitting out the fully constructed grid back to whoever calls parse file to array. This is a static method, which means that we don't need to create a new level parser. To use it, we can just say level parser.parse file to array. So if we go back to our world, go back to our game, instead of doing this, what we can do is say our 2D grid is equal to level parser dot parse file to array, and we can pass in the path to our file, so level1.txt. Then we can comment this out, and we just want to double check, so our player is being loaded at 0 for the x, 2 for the y. Let's make sure in this that works. 0 for the x, 2 for the y. So let's shift the player over, so the player is starting here. There we go. So our player is able to move around this world, and if I didn't break anything in the process, we should still be able to get through the exit and escape. So I paused the video for a second to design a slightly different level here, and I'm going to want to start the player here at 3, 3, and my exit's all the way down here. A little bit more of a maze structure for the player to figure out, a little bit more difficult. So I'm going to go back to my game, start my player at 3, 3, and I can get rid of this handcrafted level. Hit play. And we've got code that works regardless of the level that's designed. So you could ask your friend to open up ASCIIFlow and design a level for you to play. You drop it into your project and it should work, as long as they've designed it in a way that the player can actually reach the exit and that there is a X somewhere in the level for the exit. I want to show you a couple more things. So I want to bring in Figgle and Pastel like we did in the NuGet video to improve our user interface here. But I also want to fix something that is a little buggy. If we run our game and we hold down a direction, we're kind of getting, so I've let go of the down key and my game is still trying to move me down. So what happens is that the console, when we read keys, is building up a buffer of all of the keys as I hold it down, and it's going through its loop of like drawing things, waiting 20 milliseconds, drawing things, waiting 20 milliseconds, which makes the controls feel a little bit sluggish in our game. So here I've let go of the up and we're still trying to move up. So actually what we can do instead is, instead of reading a key like we're doing inside of game here, we can read all of the key presses, not just one key press. And then we can use the last key press to move the player, which basically, like if I held down for a long period of time and then let go, instead of reading that as like 30 down key presses, it's just going to grab the last down key press and use that to update the game. So we'll get a lot more smooth of an experience for the player. So I'm going to say get only the most recent key press, key input. So since we're going to get multiple things, we are going to need to create some kind of loop. So we're going to want to store the key that gets pressed, and we're going to use a loop that's going to run multiple times, at least once, a do while loop. And we want this to run as long as console.keyAvailable is true. So this property of the console class is going to give us a true value as long as there is a key press still available in its buffer, in its input stream. So because I have the using static system.console, I can omit that. So we've got this loop here that's going to run as long as there's something left in the input stream. And what we can do is bump this up. So we're going to read the key as long as there's a key available, and we'll store that into our console key. And because we're doing this many, many times, as long as there's something left in the input stream, when this loop is done, we just have the last key that was pressed available to us. So now if I run the game, so I'm holding down, it's re-rendering, I'm still holding down, I let go, it stops. So we no longer have that like long tail of whatever whatever key you've held still running through our system even when we let go. So I think now I want to integrate the NuGet packages that we've talked about to kind of improve the user interface here. So let's go through that again. Here we are going to go to Tools, NuGet Manager, Manage NuGet Package. And if you haven't done this before, check out the previous video, but I'm going to bring in Figgle. And Figgle lets me draw ASCII text. And I am going to bring in Pastel, which allows me to have more control over the color in my game. Select Pastel, install it. Okay, so both of those are in here, so we can see them in our dependencies, which means that we could start using them. So at the top, I'm going to use both of them in here. I'm going to bring in Pastel, and I'm going to bring in Figgle. And let's improve our intro. So we've got this welcome to the maze, but we could use Figgle to render that. Let's do right line. We're going to use and we've walked through how to use both of these in a past video, so check that out. I'm going to run through it quickly. So I want to use this 3D font. I'm going to render. Let's render welcome on one line, and then let's render to the maze on the second line. Great. This is looking better already. And then we can, instead of using console green here and resetting the color, we can use Pastel. So when we bring in Pastel, we get the Pastel and Pastel background methods, which allow us to specify either a hex or a system.drawing.color. I'm going to just use hex for simplicity and grab a greenish color, paste it in here. And let's check it out. So instead of being limited to the green that Windows provides us, we can now have this slightly different shade of green that I'm going to argue is a little bit more pleasing. So we've got Welcome to the Maze, we've got our instructions, and now we could look at using Pastel to improve our user interface here and change some of the colors that we're using. So it's going to be really easy to change the player, and then we'll look at the maze. So let's go check out our player, and instead of using the red that comes with the console, let's change this to be a string, and we will use a hex here. And I have a red that I picked out. And when we go to draw the marker, we can just Pastel. Make sure to bring in Pastel in any file that you are trying to use Pastel. So player marker dot Pastel, and pass in the player color. There we go, slightly different red, a little less garish. And all of these colors, I'm just grabbing ones that I set up really quickly before the video, but HSL Picker, you can run through this to grab RGB to create the system.drawing.color instance, or you can grab the hex. The only thing that you need to be careful of is that the library expects 6 figure hex, so red, green, blue, but 2 characters for each. And sometimes this tool is going to give you the 3-digit hex, which just means that instead of putting 000 into your code, you're going to put 000000. You're just going to double up each of these characters. Okay, so let's turn our eyes to our world and look to improve this color. So into my world, I am going to use this green and this white. So if my element is an X, I want to use this color, and if my element is a Y, I want to use this color. And I'm going to use a more advanced operator called a ternary operator. So I'm going to say if the element is equal to X, then our foreground color is going to be this hex. Otherwise, our foreground color is going to be this hex. So this ternary is the same thing as an if statement, where here's our condition. If this condition is met, here is what gets returned. And if this condition is not met, here is what gets returned. So we've got our green if our element is an X, and our white if the element is not an X. So then I can do element.pastel. Oh, gotta remember to bring in using Pastel. Foreground color hex. So we should see more of a pink shade of white, and we've got a different hue here for our green, which matches our title screen. The next thing that I'd want to do is that this structure could be maybe improved a little bit if we displayed a checkered pattern behind the map. So we use the background color to kind of alternate between maybe like a dark purple, light purple, dark purple, light purple. It helps visualize the grid of our game a little bit better. So we are going to create a background. Whoops. Color hex. And we're going to use the modulus operator. So the modulus operator allows us to figure out what the remainder is. So if we take y and we divide by 2, if it divides evenly by 2, we're going to get 0 back. And if it doesn't divide evenly by 2, we're going to get some remainder back. So this equation is a really simple way for us to check, is y an even number? And then if we have an else here, this would be if y is an odd number. So if our y position, if our row is even, we'll go ahead and use one color. If our row is odd, we'll use a different color. So let's do this. Background hex equals, I'm going to grab another color that I pulled out beforehand. And so when we go to draw an element, then we can use the pastel background with our background color. So super close, we've got this like striped structure, but actually what we want to do is kind of shift this off by 1 and create a checkered pattern, so that it's a little bit easier to see the delineation between this position and the next position, because they'll have 2 different background colors. So let's add that. So we're going to use another ternary here. So if we're even, what we're going to do is say if our x is even, we will go ahead and use this color. Otherwise, we will use this color. So let's see what that looks like. So we're getting there. This first row we can see is alternating colors between purple and darker purple, but it's only happening on our even rows. It's not happening on our odd rows. And if we just copy and paste this in place, that's going to make it so we don't have a checkered pattern anymore. We now have vertical stripes. So what we want is for this checker pattern to stay and this one to shift the colors by 1. So instead of this being purple, that should be black. This should be lighter purple. That should be black. So what we can do is just reverse the colors that we're using here. If we run it, there we go. We have kind of a checkered background behind our game so that it's a little bit easier to tell the difference between each position in our map. So that's basically all I wanted to show you in this video. We figured out how to load levels using ASCII Designer, an ASCII Designer which will make the workflow so much easier for laying out worlds that a player can explore. And we looked into using some of the NuGet knowledge that we had to improve our colors. And we learned a couple new operators along the way, which may be challenging initially. Spend some time with them. They'll start to make sense. Just to sort of clarify another way that we could do this. So I'm going to comment this out. Any of the ternary operators, if you're trying to work through what they mean, you can just use an if statement in place of them. So this condition goes in here, and then foreground color equals the first thing that we passed in, else foreground color equals the second thing that we passed in. So these two chunks of code are equivalent. A ternary operator is just a terser way to express this kind of if-else logic. And we also introduced the modulus operator, which allows you to check the remainder, which the way that we used it was to see whether a number was even or odd, and that let us create this kind of checkerboard pattern. There's a lot of cool stuff that we could do with this structure now that we've set it up. Like we could add more things to our world. I would challenge you to try and add, like, maybe there's a collectible item, like maybe the player needs to pick up a key before they can actually get out of the exit. But I'm not going to show you that in this video. So go forth, use these to improve your mazes, and have fun.